guys, welcome to the channel. In this video, I will show you how we implement insert function. In insert function, we insert an element after the nth node. Means we have given the node number and we have to insert the data element after that node, after the given node number. Means we have if we have to insert, we can say insert after inserting an element after the nth node. N can be 1 or 2 or 3 or 100, whatever. Okay. For this, if here in the first line I have written insert 1, that is 1 is our node number. First in insert function, insert function, we have two variables, node and our data variable. Okay, it has two variables, node and data variable. Node is also integer type variable and it shows the node number. Means if we count here, this is there is three elements in our list, 1 2 3. 1 has node number 1, 2 has 2, 3 has 3. Okay, if we have to insert after 1, we will pass 1 and 10, and we will insert like this. 10 will be inserted between 1 and 2. After 1, 10 will be inserted, and after 4, 100 will be inserted. Means now 100 will be inserted after the fourth element. This is first, second, third, fourth. Okay, now 100 will be inserted after the fourth node. Okay, now here we have to insert after the -1 node. That doesn't exist. -1 doesn't exist in our node. Our node start from 1 to n. Okay, it can be 0 or less than 0. Okay, it can be 0. It will give invalid node. Okay, in the output. Okay, for inserting an element after the given node, we have to first check if the node, if we have entered, if the user have entered the valid node number or not. And after that, if we have to check the size of the list. Suppose if we don't have any element in if we have empty list, then in this case size will be 0, and if size is 0 or less than 1, it will be invalid node. Okay, now let me take you through my code. I have written already here. This is our insert function. It has two parameters, constant int node and constant int data. Okay, now this is what I was talking about. If node means node number is less than 1, means if we put node minus 0 or -1, it will pass a message invalid node. And also if size is less than 1, means if size is 0, it will give invalid node. Okay, and return. This is void function, that's why we don't need to return anything. Okay, now after this we will create a temporary variable, and we will allocate a block of memory, and we will assign the data value to it, and after the temp variable we will put null. Why null? Why I have uh, given null to it? If we have to insert after the nth element, means if we have to if I have to insert after the 100th element, then temp variable will be here, and after that temp variable, after the data, we have end of our list, means we have null pointer. Okay, we will have null pointer, that's why I have written null here. Now we will iterate over over the each node. For the iterating, I have created current node that is equals that has the address of first node, and we will be advancing the current node, uh, and we will count each node. Okay, here if here this is our loop, current node is not equal to null. When it is not equal to null, we will spin we will our loop will be executed. Okay, while loop will be executed, and if node number becomes equal to I, we will break and will come out from the loop. Okay, otherwise we will advance the current node and we will go to next node and we will increment I by 1, and when we get, suppose we have to insert, suppose this is our list 1 to 4, and we have to insert after the second element, after the 2. Okay, then current node will be here. After that it will, after the advancing, it will be go to 2, and node is 2. If 2 equals 2, I will be 2, and if I equals 2 and node equals to I, we will break, and we have now current node pointing to 2. Now here current node is pointing to 2. Okay, for the keep tracking of current node and counting the node number, I have used I. Okay, and temp temp has the data variable. Temp has the data variable. Suppose we have to insert, we have to insert 3. Okay, and our temp has data variable temp to next equals to current node to next, means this is our current node. Here current node is pointing to 2, and current node to next will be pointing to 4, and temp to next will be pointing to 4. Okay, now temp to next will be pointing to 4, and now current node to next now temp to next is current node to next, and current node to next will be our temp, means we have 3 on temp variable, and 3 to next means we have 3 to next. Here let me show you 3 to next. 3 to next will be, I'm just writing the data object, not pointer. Okay, 3 to next will be 4, and here it will pointing, and now current to next, current is 2, and 2 to next, 2 to next will be temp have 3, means we can say 2 to next is 3 and 3 to next is 4. In this way we can see we can say that I've inserted 1 to 2 after 3 after the 2. Okay, hope you understand how it has done. If you don't understand, you can ask. If you have any doubt, you can ask in comment section. Comment section is open for you, all you guys. Okay, this is how we insert after the nth node. Okay, and this is our size function. I've used size function for checking the validation of node. Okay, this is our size function. This is count variable that is equals to 0, and here it is same as current node, and it is same as we iterated in the previous function. Current node equals current node have the address of first node, and current node doesn't equal to, if current node is not equal to null, or we will move into the loop, and we will advancing counter variable. We will advancing counter. We will be advancing counter by 1 and current node by 1 element. Okay, and we will move one by one to the right. Okay, and at the end we will return counter variable. If here, if we have 1 2 3 4, we have 4 element, it will, our loop will be executed 4 times and count will be of 4. Counter variable will be, first it is 0, now it will be 1, after that it will become 2, after that 3, after that 4. Now 4 will be returned. Okay, it is simple as we did in the traverse. Okay, now let's call first of all, let me show you the validity of now let me show you what we have in our list. I am printing size. Okay, here size will print 0, and here if we traverse we don't have anything, that's why we have empty space here. Okay, now if we insert 5 elements to it, we will push back 5 elements. Let me print. Now we have 5 elements, 10 11 12 13 14, that is size is 5, size is printing to 5. Okay, now we will insert 1 now first we will insert after the zeros node. Let me put 0 here to show you. Here it will give invalid node and traverse and after size. If we put 10, guys, note that we have only 5 elements into the list and we are inserting after the 10th element. Let me show you what it returns. Sorry. Right. Now I'm modifying my code. If size is less than node, means here is the case. I forgot that. Uh, Here is the case. We have only 5 elements and we are inserting after the 10th element. Okay, that's why we will compare from the size. If size is less than node, okay, it will give error. It will give invalid node. Okay, now we will put 1 after the first node. Let me show you. Here you can see this. This was our at the node 1 we had 10 and node 2 11. Now node 2 have the element 1 and node 3 have 11. Okay, and now we can insert 100 after the first element, after the first node. Here, oh, let me shake the code. Here we have 100 after the first node, and size has increased. Previously it was 5, now it has 6, and here it is 7. If we put 5 after the second node, here you can see after the second node we have put 5. Previously node 3 had 1, now it has 5, and node 4 previously had 11, now node 4 had 1. Okay, or all the elements are shifted. Okay, this is how we insert after the nth element. Okay, hope you understand the concept. And inserting means I have shown you the pushback function, push front function, and insert function. Okay, and size function and traverse function. Okay, hope you understand. If you understand the concept, please like my video, share with your friends, and subscribe our channel. Okay, thanks for watching. Happy coding.